not big enough to keep the all students, so I changed the location of the exercise lab. So right now it's 1:30. Okay, the time is the same. I believe that you already got the email from the Omar or department regarding to the Oracle database account, right?
Yeah, he already created the account, but I didn't email the
okay.
student.
So the GA will let you know later. But next week we don't need any Oracle account, so you can just come on and attend the practice of the array software. And first phase of the database design, the project A is due on the next week. So in this case, you need to do the problem definition. For undergraduate student, it's optional whether you are going to form a team or not. So you can make the team by 2 maximum, but if you want, you can do the individual. Okay, so but for graduate student, it's the individual project. The topic of this semester is the online banking system. I believe that everybody has the banking account. Also, you are using the online banking. You can get the idea of this project from the online banking system that you are currently using, but you can add more or you can change the functionality. So based on your idea, why don't you submit the first page of the project that is for that should include your problem definition, details of the problem definition, as you have seen in the sample database design requirement. You can specify, but I briefly I gave you the minimum requirements such as customer management, balance inquiry, deposit withdrawal, fund transfer. Is just a high level overview of your project. So you need to detail each function. Some of them you can implement, the others are not. So you need to specify what you are going to design in this project. Then also formulate, in step 3, formulate in English at least a 15 realistic query. You don't have to worry about, even though you do not know anything about the database query or database, just plain in English. Okay, plain English state the problem. So realistic, for example, user A can retrieve the balance by week or by month. That's it. Okay. That's what I want in this step 3. Then eventually you will implement such a realistic query in database language later after you learn it. But this time you can just imagine and design based on your experience and ideas. Okay? And also you can specify any assumption you have. For example, this is the single branch the banking system, or it can communicate with other bank, but just pretending. Also, you can have the credit card, the service, but you do not have any real transaction. Also, balance transfer. Where do you transfer? You cannot do that at the time. You can just pretend such a thing. You can specify such a assumption of your system. Also, make the plan as just like you are doing real project. So based on the schedule that I gave by page 2, page 3, page 4, so you can make the plan of that. Okay. So pretty much the first page, during the first page, you need to submit the documentation only. Okay? You don't need any other thing. It's a documentation. Even there's no design or design tool or logical model. No, we don't need it yet. Okay? It's just the project initiation. Any question regarding to the project? I know some of you guys already did it in your undergraduate or the previous class. So, but it's a little bit extended. Yes. Oh yeah, you need to submit to the campus. Okay, you don't have to bring in the classroom. I will not accept any handed in the classroom. Any other question? So one more time, this is the individual project for the graduate student, but this can be the group project for undergraduate student. However, this is only the required project for undergraduate student, so you should. If you fail this one, I don't think you can recover. So please do your best to complete the project. Okay. So each step before, throughout the semester, probably I will spend a little bit of time how you can do the next step. Okay. One more thing is we will learn later the database programming. So eventually you need to implement the application part. At the time you need to do the implementation. Regarding to the program language to implement your database application, there's no restriction. You can use any program language. You can use the Python, you can use the Java, you can use the JavaScript, you can use the .NET, you can use the C++, you can use just the C language. It's okay as long as your program language can support graphical user interface. Okay, it can be the web interface, totally fine. Okay, so let's quickly
Yeah.
Okay. So let's quickly review the logical modeling that we have learned the last time. So right now what we are doing? What are we doing right now? So we are doing the designing the database from information given by your customer, whether your requirement, we'd like to build a database. So we need several steps to build a database. So this is the first step, very first step to model the information to data. Okay? There might be a huge amount of information given by your customer or your daily life. We don't need all the information. Instead, we try to find the meaningful information as a data. Then we need to organize. How can we organize? There are rules, policy, okay, which is model. Especially in this class, we are going to use ER model. ER model is just one of the examples for logical modeling. There are a bunch of others. So you can use, you have been used what? The object-oriented model, the network model. Yes, you can use the hierarchical model. Okay? Among them, we are using the ER modeling. So the step of such an ER modeling starts with what?
Requirement.
So first step is entity. We are going to find entities. Every entity type. What is the entity type? This entity type is a common structure of the bunch of entities. Okay, like the student one entity, another entity. Then I realize these entities forms student entity type. Okay, but from now on, we are going to use the entity type, entity set interchangeably. The same meaning. So entity can be represented by the rectangle. So in our simple example company database, we can find how many entities. First, employee. Also, we have department. Also, we have project. Also, we have dependent, right? For each entity, next step is find all attributes. That attribute describe the entity. Okay? Then we can use over and the line to connect the entity. So SSN, name, address, what else? We have salary and sales, what else? DOB. Date of birth. Then we can find also key attribute that can represent the entity. Okay? In other words, if we can identify specific employee using that attribute, that will be key attribute. Sometimes you can have many attributes in one entity as a key attribute. Sometimes it can be composite attribute. So at the time you can connect them. What about the department? Department, we have number, we have name, we have manager, and starting date. What else? Location. Okay? Then we can use the number, we can use the name as a key of department. So there are two key attributes in this entity. Also, in case there are multiple values, 1, 2, or more values for each attribute, it can be multi-valued attribute. We can use double forward. We will discuss later why we need to specify the multi-value. Okay? Set aside right now. What about the project? Project, we have unique name and number and location. In this case, read kindly, your customer mentioned it's a single location, so it's different. Also, it has two key attributes, just like that. Okay. And dependent, we have name, sex, DOB, and relationship. But however, we cannot find the key attribute of the dependent in this case. It's okay. There's no problem. Whether or not there is the key attribute in entity. The problem is we can identify specific dependent entity in this so far. Who will take care later? So this is the output of up to second step. Very simple. So this is mostly E part, entity part. The next step is identify relationship. As the name implies, the ER modeling actually stands for entity relationship modeling. So relationship, employee works for department, right? So we can find many relationships from here. Actually, employee Lee works for HR department. Hotel works for HR department. Who works for a specific department. By grouping, we can find works for relationship type, actually. But as we, just like what we have done in entity type, we are going to use relationship instead of relationship type. Okay? Then we can find another relationship. It's the manage. Some of employee manage the department. One employee manage one department. So you don't have to keep the manager is here. So this is a manager. We don't need it because we use the relationship over here. And also department control project and employee works on specific project. Also, we can manage hours of. So, for example, Lee works on project A 10 hours. Lee works on project B 20 hours. Something like that. Okay. James works on project A 5 hours. James works on project D 10 hours. So we can identify works on then their attribute. Even relationship can have attribute to describe details of that relationship. There's no problem. Others. Also employee, supervise, employee. At this time, employee, supervise, employee. How many entities? So one entity, but actually employee, supervise, employee. They have the relationship. Actually, one entity has a relationship. This is called recursive relationship. For example, CEO supervise several vice president. Vice president supervise manager. Manager, manager, manager supervise other employees. All of them are employed. Even vice president is a supervisor as well as supervising. Okay? So that's the recursive relationship. Anything else? We have one more relationship over here, that is has. Employee has dependent, right? But this time, dependent, we cannot specify which dependent. In case we have two Nicholas, need from employee Lee and employee James. To identify the specific dependent, we need to use key of employee, okay? Which means social security number of employee. So this time, if we can borrow the key of other employee, which has a relationship, that is SSN, like that. This is called weak entity. Weak entity does not have the strong key attribute. Instead, it has only partial information. So, how can we differentiate such a weak entity? We can use double rectangle to represent weak entity and relationship and attribute, and also weak entity. It is double rectangle. Also plus relationship can be double diagonal. So this is called identify relationship. Then using this relationship, you can identify the entity in weak entity. Okay? Yes. This one? Number 2? Here? Number 2? Yes. Yes. This is the attribute of relationship. This is the attribute of entity. Okay? So, this is the ER modeling. So output of ER modeling is ER diagram. Very simple. That's one of the benefits of using ER modeling. Okay? And easy to understand is that compare the description of the disk and the ER model. Which one is easy to understand? Definitely ER diagram is easy to understand. Also, it's very simple, so that due to the simplicity, you can easily convert this ER diagram to other model. Okay? Any questions so far? So, because you do not have any question, test. Because you didn't have pen. So this is the practice of your ER modeling. So it's a very simple data. Do you have? Anyone? The question is, we are going to design the UPS database. UPS provide design on the having up-to-date information on the processing and current location of each ship item to the disk. Okay? UPS rely on company-wide information system. Ship items are part of the weight, dimension, insurance amount, destination, and final delivery date. Ship items are received into the UPS system at a single retail center. Retail centers are characterized by their type, unique ID, and address. Ship items make their way to their destination via one or more standard UPS transportation event. That is, flight, truck, delivery. These transportation events are characterized by a unique schedule number, a type, and delivery route. It's a little bit more complicated than company database, right? Even this is very, very nice description comparing to the real code. But it's for your practice. How can we model this? You can start from entity. You can find entity. First, why don't you find entity? Then you can use the specific symbol, but why don't you follow this, the diagram symbol? So why don't you, the rectangle, any candidate of entity first. That is most important. And you can find the entity correctly. I think the 78% already. So, what can be the candidate of entity? Actually, entity type, right? We decide. My promise. So we are going to use the entity instead of entity type. What can be the entity? So it's clearly mentioned. Ship, island, something blah 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 blah, right? What about the UPS? Is that? You don't have to. That is the title actually, right? But if you build something, for example, Expedia.com, okay, for travel agency, at that time you need to keep track of each company information. But this is only for UPS system. You don't have to keep as a database. All right. So first candidate is a ship, island. Okay. What about the other?
Retail center.
Retail center. We have the retail center, right? Then such a ship island will be collected by retail center. Then anything else?
Destination.
Transportation center, right? It will be sent to the transportation event, right? It's a transportation event in a center. Anything else? What do you think? Yeah, that's sometimes very difficult whether this is called for the attribute or this is called for the entity. Okay? If you have additional information to describe that, it can be entity. Otherwise, it can be part of the attribute. Okay? So I think it can be attribute. Anything else? What about the transportation type? It can be attribute, right? However, if you have very detailed information about the type, then you can have another entity. One. For example, we have transportation event and as an attribute, the type. This type has a very detailed information. Very low and frequently updated. What if, for example, transportation event, when you have the different transportation event, and this is the same type, truck, for example, truck. Whenever you update this one, you need to update all truck type. Just a long time. So at that time, you can consider this type as the entity. However, in this case, it's nothing but truck or fly. Okay, it's so simple. So it can be an attribute. So I think pretty much there are three entities. So the next step is find the attribute for each entity. Until you find, why don't you use over and the line to connect corresponding entity. Also, after you identify all attribute, find the key attribute if any. Why don't you do it by yourself on your sheet? I strongly suggest you, even though you understand everything right now, create the draw ER diagram with your handwriting by yourself. Okay? I have seen a lot of the students who fail the exam. They believe I know everything. I have several years of experience on the database modeling, but they fail on exam. I do not care your number of experience when I grade the final, only based on your score. So please. about the sheet item? We have, the first one is the
Item
number. That's unique. Kindly is mentioned unique, which means it can be key attribute, right? Then weight and dimension and so on. Okay? You can find as many attributes as possible. The next, retail center. For retail center, where's the retail center? Yes, retail center are characterized by their type,
ID.
unique ID that definitely they can be key attribute. Then address. There's no further information about address, so you can use as a regular attribute for this. However, if your customer mention about the details of address or your application program require some details like the zip code, town name, state name, and street name, street number, you can use the composite. Okay, then what else? Transportation event. What can be the key of this one? It's a unique schedule number. So we have the schedule number that is unique. Then type, already delivery, no. Okay, that's it. The next step is relationship. Why don't you identify the relationship? Then using diamond and connected line, why don't you complete the step 3? How many relationships can you find? Two. One is
Received.
received means each item is received at retail center. Okay? Received. Another one is the shipped or delivered. Right? Which one is better? Shipped. Using the transportation. Any further information to describe the relationship? According to the requirement, there's no. So that's it. Very simple. So I don't have to grade your exam. Then, is that all? No, there is several more steps to complete to make the ER diagram details. First one is, the next step is, why don't you take a look at this relationship? The works for. Employee works for department. How many employees can work for the department?
Many.
Many. Okay? Lee can work for the HR, and James also, and the Patel also, the Clinton also. There are many employees who works for the one department. Is it possible one employee works for the several departments? Why don't you read the description? No, only one department. So we can say that this is the many employees works for one department. What about this one, manager? How many managers for each department?
One.
One, right? And also, how many departments can each manager can manage? One or sometimes none, right? If non-manager, definitely not. So maximum one. So one. It's different from the works for. Works for is many employee works for one department. One employee manage one department. So this is called the cardinality. Cardinality you learned. When did you learn such a cardinality? In your elementary school. Can you remember this one? There are two sets. This is A, B, C, and this is 1, 2, 3, 4 mapping. 1-to-1 mapping. Or sometimes many-to-one mapping. Or one-to-many mapping. Also many-to-many mapping. This is called the cardinality. It's exactly the same thing. Why? Eventually, we will consider such a set theory to use this year diagram. So we can represent such a cardinality formation in each relationship. Either one-to-one, one-to-many, many-to-many relationship. Okay? What about this one? It's a many-to-one relationship. Don't be confused. I promise there are many students who fail to specify many-to-one or one-to-many. So this is even, sometimes I get confused. So many employees works for one department. So many-to-one. Okay? What about the many? One-to-one. What about this one? Is it the one-to-one or one-to-many, one many-to-one, or many-to-many? Department. One department control many projects. So it's a one-to-many. What about the employee and dependent? One employee doesn't make sense. So I'm dependent. Do I have? Oh yes, it makes sense. In case father and mother, both parents are working in the same company. But in this case, we don't consider such a thing. So it's a one employee has many dependents. One, two, many. Also, in case, I will explain later. What about the supervisor? How many supervisors do you have? One supervisor. Okay? But not always true, but in our company database, it's so clearly mentioned. One supervisor and many supervisors. Okay? So, one, two, many. If you want to specify details, supervisor and supervisee. Okay? What about this one? Works on. Professor, the employee Lee works on project A. The employee Lee works on project B. One to many. Also, one project, one employee can work many projects. And also many, one project may have many employees. Many employees works for one project, and one employee works on many projects, which means it's a many to many. Okay?
Did you say end to end?
Yeah, many to many, end to end. Okay. To represent. That makes there's no specific meaning end to end or end to end, but the end or end represent many sides. Okay? So this is called cardinality. There is another condition you need to specify on the relationship is, what about this one? Employee should work for at least one department, right? However, employee sometimes manage, sometimes not. Okay? So, whether this is a mandatory relationship or optional relationship. If this is a mandatory, you can use double line. And single line or double line. Single line means it's an optional relationship, optional participant. While double line means mandatory. So in this case, managers, some of the employees manage the department, but the others are not. So this is an optional. However, employees should work for one department. So it's a mandatory. So similarly, we can find department. Sometimes department can control the, let's see, each department control a number of projects. There's no mention about must or should. So it can be optional. However, project should be controlled by department. Okay? And also dependent should have employee. Right? However, employee sometimes has the dependent, sometimes not. So singular option. And employee sometimes works on specific project, sometimes not. And project may, is there any mention about the let's see, project. Each employee works for one department, but may works on several projects. Okay, so may, so it's a single line, and project should have the employee who works on this department. Then it can be double line. But it's not clear if you read the description whether this is mandatory or not. So at that time you can specify, you can note with why this is mandatory, why it's not. Then that's more clear. That's it. What about this? Ship item. There's no mention about such a mandatory or the optional. However, we can identify the cardinality. Ship items, retail center. So many to one. Okay? One retail center can collect the many shipped items. However, can you drop multiple locations for one item? That doesn't make sense. So it's a one to many. What about this one? Ship items sometimes fly and truck. Fly, truck. Truck, fly. There are multiple. So it's a many. What about each transportation event? Definitely a lot of items, right? So it's a many to many. So let's review quickly the conceptual design using the ER model. The most important part is whether you can identify the proper entity type. Then find the attribute for each entity. Then relationship between two entities. Yes.
I think in the transformation, how does it happen in one?
For example, one item can be delivered via truck and the flight. Is there any mention about that? These transportation events are characterized by a unique number? No. Retail center and blah blah. Shipped item make their way to their destination via one or more standard.
Yes.
Right? It's a one or more. It's a many. Also, each transportation event, how many items in one truck? Many items, right? So it's a many to many relationship. Okay? So after you identify the entity, you can identify the relationship, then followed by their own attribute. Then decide whether this is the mandatory participation or the optional participation relationship, or one-to-one, one-to-many, many-to-many relationship. That's the ER model. Okay, so this is the output of the ER model. You can see in this case, specify the mandatory participation of employee and department on work scope, and department should have the manager. And also this one, and in this case, the employee should work. That's the difference from the what I did. Okay, but you can understand the difference. Okay. Is there anything that I do not explain?
The docket.
Yes, dots. Number of employees. Can you guess what that is? Why don't you take a look at the requirement? Does the requirement description mention about that number of employees? Probably not. You cannot find it. But after, I guess, after designer analyze the application program, many of the application program access number of employees for each department. Actually, that number of employees for each department, you can access employee. Then count all employees for specific department, right? It takes a longer time. Why don't we keep such a number of employees in department as an attribute? How can you count number of employees? You can count employee entities in employee, which means it's derived. Okay? It can be calculated from other information. At the time we can use dot over to represent this can be calculated, derived from other information. Anything else? Okay, pretty much done. That is the ER modeling.
So there's no one answer, right? You could have, like you said, this works for, I could use some other terminology. I mean, there's no particular answer. It could be.
Oh yeah, sure. If we want, you can make
Come up
a
with my
different.
own different.
Okay, then, if you take a look at the output of the company database model for ER modeling, sometimes it's not very clear whether is there any maximum number of employees for each department or project? No. It's only mentioned about whether this is optional or this is the mandatory. So in case you need more specific information about the entities in relationship, we can use the min-max notation. So min-max notation, instead of the n or 1, we can specify the minimum number and maximum number of entity in this case. This is a good example. So, in terms of department point of view, how many employees are manager? Minimum.
One.
Minimum 1 manager. Maximum
One.
1 manager. What about this one? for each employee, how many departments each employee can manage? Minimum, some of them are 0, nothing. Even though you are manager, how many departments maximum? 1. So it's more specific information. So if you need more specific information, you can use minimum, maximum of this one. At that time, we don't have to use a double line. For example, here, employee. For each employee, how many departments? Minimum. At least 1 department. And maximum 1 department. For each department, maximum 1, minimum 1, maximum n. Something like that. So let's take a look at the example of the min max notation. What about this one? Employee, yes. That is the same as what I explained here. Employee, minimum 1 department works